Hello students. So last class I have given you few information regarding the successible attempt towards classification of elements. So finally we will discuss now long form predictable or modern predictable. Okay, that was proposed by your Moseley. Okay, Moseley. So that is first one. We should write about modern periodic law. Modern periodic law. So according to modern periodic law, what is the statement? The physical and chemical properties of the elements are the periodic function of their atomic numbers. Function of their atomic numbers. That means elements are arranged with increasing order of their atomic numbers. That is, elements are arranged with increasing order of their atomic numbers. Okay, so now let us draw the long form periodic table. Okay, and you know long form periodic table, or you can say modern periodic table. Modern periodic table divided into 7 horizontal rows called groups. Okay, called groups, and 18 called periods, and 18 vertical columns known as groups. So long form periodic table having 7 horizontal rows called periods and 18 vertical columns known as groups. Okay, so let us try to represent our long form periodic table. Okay, let us try. So long form periodic table, you see if I do like this, this one, and here that is your hydrogen. Next lithium, sodium, potassium, rubidium, cesium, francium. This one, and here barium, magnesium, calcium, strontium. Clear? You see, so this one is the group first. So if I represent it, it will be your 1A according to Mendeleev's. So this one second A. Okay. Next, from this calcium, these are called the transitional element or D block elements, from group 3rd to group 12, like this. That clear? So after scandium, after calcium 20, so if you mention their atomic number, so hydrogen 1, then you just add 2 over 1, so that will be 3, then 8, add 8, that will be 11. जैसे ये नंबर है ना, 2, 8, 8, 18, 18, 32. Okay, so 8, 11, again 8, that will be add 8, that will be 19. Clear? So 19 you add 18 over here, that will be 37, and 37 plus 18, that will be 55, and 55 plus 32, that will be 87. So you get the atomic numbers. Clear? So next element, that is after calcium, you know the elements, that is scandium 3D series starts, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and the last one, that is zinc. This one. Clear? So here you see, this is 3D series, and next that is your 4D series. It starts from yttrium, niobium, technetium, ruthenium, cadmium. Okay, next that is 5D series, the lanthanum, mercury. Okay, and this one, that is 1 2 3 4 5 6 7 seventh period, and the seventh period, you know, this is incomplete. Okay, so this is incomplete period. I am not mentioning these elements right now. So this is actinium and RF, DB, all these elements are there. This is incomplete, don't bother about that. Next, from here, let's see. So here this one, and do like this. Six. Okay, or let me 6, that will be here. Two, 3, 4 5 6. Okay, 1 2 3 4 5 6, that clear. Now here this one is helium, atomic number 2. So you can do like this. So from here, boron, aluminum, gallium, indium, tellurium. Okay, like this. So seventh period, you don't bother about that. Next, that is carbon family starts. Germanium, carbon, silicon, germanium, tin, lead. Next, that is nitrogen, phosphorus, bismuth, antimony, bismuth. Next, that is polonium. Okay, next bromine, iodine, astatine, neon, argon, krypton, xenon, radon. Clear? So if you mention their atomic number of these elements, so it's very easy. You can apply this technique, that is addition of magic numbers, or you can proceed like this: hydrogen 1, helium 2, 3, beryllium 4. Okay, so this boron 5, 6, 7, 8, 9, 10. Next 11, 12, 13, 14, 15, 16, 17, 18. This is 19. Next 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54. Next 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 70. Oh, sorry. So here beta, you just see, sorry. This after lanthanum, so after lanthanum, here there is a star mark you see, and here actinium, this is star mark. So after this 57, you know the atomic number from 58 to 71. These are known as lanthanoids. These are known as lanthanoids because these are 14 elements and placed just below from cerium, that is lanthanoids. And here from actinium we'll see, so 71, so here starts 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85 and 86. Is that clear? So 87, this red one will be 88 and this actinium is 89, and you know from 90 to 103, 90 to 103, the 14 elements, these are called actinoids. These are your actinoids. These elements, rare earth elements present below, rare earth elements present below the periodic table. That clear? So these are the representation of elements in long form periodic table. So if you mention the group, so that will be 1A, 2A, this one will be 1A, 2A, that will be triple IA. So if you mention the group number 1A, 2A, 3A, 4A, okay, 5A, 6A, 7A, then from here to here, this is group 8th group, third I. Next this one, that is 1B, 2B, 3B, IVB, VB, VIB, V theta I, B, and this one is 0 group. Okay, this one is 0 group. Next, in simplest way, you can mention this one as first group, 2 second group, third group, fourth group, fifth group, sixth group, 7th, 8, 9, 10. Okay, 11, 12, 13, 14, 15, 16, 17, and this one is 18 group or 0 group. Clear? So if you mention the periods will be, this one is your first period, this one second period, third, fourth, fifth, sixth, and seventh. Clear? Now, how this classification has been made? The basic fundamental property that elements having similar valence configuration are placed together in a group. So you see, so this first group known as alkali metals having configuration NS1, alkaline earth metals NS2. Is that clear? So let us back to this side. You see here boron family, its configuration is NH2 NP1, is that clear? I can write over here NH2 NP2, NH2 NP3, NH2 NP4, NH2 NP1, 2, 3, 4, 5, NH2 NP4 will be this one, NH2 NP1, NH2 NP2, NH2 NP3, here I have done wrong, NP3, NP4, NP5, and this one is NH2 NP6. Okay, group 18 elements, NH2 NP6. The genuine electronic configuration, general valence configuration remains same, that's why these are put in a particular group. So that means the groupism has been made upon the similar valence configuration. Okay, so here you see these 1A elements, these are first group elements, these are called alkali 1A, these are called alkali metals, and group 2 elements, these are known as alkaline earth metals. Okay, and this the middle portion of the periodic table, these are D block elements or transitional elements, you can say, from group 3 to group 12. Is that clear? So here particularly in this side, these are non-metals and the P block elements. Here this one is your P block elements, because the last electron enters to P subshell, NH2 NP1, NH2 NP2 likewise. And here this group 1 and group 2, these are your S block elements, alkali and alkaline earth metals. Clear? So these are active metals placed in group 1 and 2, and from group this one 13 to 18, these are P block elements or non-metals, or you can say these are non-metals. Okay, so from this silicon, okay, silicon, germanium, and this arsenic, is that clear? Then this here there is a diagonal relationship, that means these exhibit the property of your this one and this one. There is a diagonal relationship, and this diagonal relationship indicates, okay, this one, these are having characteristics of metalloids, metalloids means having properties both metal as well as your non-metals. These are metalloids. These diagonally elements, their properties, they having properties of metals as well as non-metals, so that these are called as metalloids. Clear? So if you mention their electronic configuration, no problem, you can mention it. This hydrogen 1s 1 valence shell configuration I am writing over here. Next, this is helium 2s1. Okay, next that is neon 3s1, and here argon 4s1, and this one krypton 5s1, fifth period. Next, xenon 6s1. Next, that is radon 7s1. Likewise, these elements, just remember, these are active metals, and these diagonal elements are metalloids, while the above all these elements are non-metals. And group 17 elements, this one, okay, group 17 elements are known as halogens. They mainly, these elements are obtained from seawater, from sea, so that these are known as halogens. And group 18 noble gases, group 18 noble gases. Clear? Next, this boron family and carbon family, this nitrogen family, nicogens, oxygen family. You know, this oxygen family are known as chalcogens, ore forming elements, and these are halogens, and these are noble gases. And the elements which are present from group number 3 to 12, these are your elements are your transitional metals. Clear? Now, since the last electron enters to the S subshell, that's why these are known as S block elements, and there you show the additional electron enters into P subshell, NH2 NP1 NH2 NP2 NH2 NP1 NH2 NP2 NH2 NP3 NH2 NP4. Likewise, so these are known as P block elements. And here I have told you the electrons are entering to the D orbital or D subshell, that's why these are known as D block elements. I have told you this I can here NH2 configuration you can mention over here, helium 2s2. Clear? So here neon 3s2, argon 4s2, krypton 5s2, xenon 6s2, radon, and here that is radon 7s2, 86 to 88. Easy. Okay, then these are transitional elements, and this boron, that is NH2 NP1, so that will be, this one is second period, so its valence shell configuration will be 2s2 to P1. Clear? So after helium, so here will be 3s2 3p1, 4s2 4p1, 5s2 5p1, 6s2 6p1. Easy. And this is carbon number 6 NH2 NP2, so that will be 2s2 2p2, 3s2 3p2, 4s2 4p2, 5s2 5p2, 6s2 6p2. Clear? So NH2 NP3, that will be 2s2 2p3, 2s2 2p3, 2s2 2p3, 2s2 2p3, this one, that is 3s2 third period 3p3, 3s2, 3p3, 4s2, 4s2, 4p3, next 5s2, 5p3, 6s2, 6p3. Clear? Next this one is 2s2, 2p4, 3s2, 3p4, 4s2, 4p4, 5s2, 5p4, 6s2, 6p4. Clear? Next this one 2s2, 2p5, 3s2, 3p5, 4s2, 4p5, 5s2, 5p5, 6s2, 6p5. Likewise, so ns2 np6 configuration. So this one will be first period, second period, first period this one helium is gone like this, 2s2, 2p6, 3s2, 3p6, 4s2, 4p6, 5s2, 5p6, 6s2, 6p6. Noble gases having valency 0. So again, this is transitional elements. So first one, that is this series is called first transition series or 3D series, and its configuration I have told you. After argon 18, here you just see noble gas core is argon 18. So after argon 18, this one I have told you argon 18 goes like this. So 3d1 4s2. That clear? So here again 3d2 4s2. You see electrons are added to 3d, that's why these are d block elements. 3d2 4s2, 3d3 4s3, and in case of a chromium I have told you this will be 3d5 4s1. Valence cell configuration I am writing over here. So manganese 3d5 4s2, iron 3d6 4s2, cobalt 3d7 4s2, nickel 3d8 4s2, copper 3d10 4s1, zinc 3d10 4s2. This is the configuration of a 3D series. Is that clear? Next 4D series. This is second transition series. In second transition series, again write down its configuration like this. So here you see we have to mention the electronic configuration of 4D series. A trick is there. You just write down 1 2 3 4 5 6 7 8 9 10. ठीक है? So 3 6 9 को नहीं लेना है, तो 3 6 9 कैंसिल कर दीजिए, तो 1 1 2 2. Okay, and just see I am doing again over here. Just remember like this. See here, D subcell having 10 electrons, 1 2 3 4 5 6 7 8 9 10. Okay, so you can take 3 6 and 9, 3 6 9 you can take. Okay, so and you know this 5 is half filled, this table remains like, and 10 this is full filled. Just write down like this. So 1 means 1 electron, 2 means 2 electrons, 3 नहीं लेना है, उसके बाद कौन है 4, so 4 already you have taken 4, so next one that is 5, so 5 5 it's okay. So next 6 नहीं लेना है, तो उसका next digit that is 7. Okay, 7. Okay, let me manage this one. That is 7. 7 you have already take. Next one that is 8. 8 you have already take. 9 you can take. So next digit is 10. So 9 it will be 10. 10 10. So this is the trick to represent the number of electrons in D subcell of 4D series. Okay. So in 4D series, yttrium that is 39. So that will be krypton. After krypton, the configuration will be 4d5s. How many electrons in D? 1. 1. So you just add krypton 36 and plus 1, that will be 36, 37. 37 you just deduct it from this 39, that will be 5s2. So you can mention like this, that will be 4d 5s 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 4d 5s. Okay, just mention the number of electrons, 2 4 5 5 7 5 5 7, mention over 4d 5 5 7 8 triple 10 8 10 10 and 10. Is that okay? So you just add 36 with the number of electrons d and deduct it from their atomic number. If a 36 plus 1 37 39 2. Okay, so here 2 electrons are there in d, so 36 krypton 36 plus 2 38, so that will be 2. 36 plus this 4 will be 40, that will be 1. 36 plus 5, this will be 41, so that will be 1. 36 5 41, that will be 2. 36 7 43, that will be 1. 36 8 36 plus 8, that will be 42. 43 36 plus 8, that will be 44, so that will be 1. Next 36 46, that will be 0. 46 1 46 2. So this is the configuration of your 4d series. And for 5d series, you can take 8. Okay, 1 2 3 4 5 6 7 8 9 10. Then you know 5 half filled stable, 10 full filled stable, and you can take 8. So you just 1 1 2 2 3 3 4 4. Okay, next 6 6 7 7 8 you can take. Next digit is 9 9 you have already taken, so that is 10. So these are the electrons present in d subshell. Okay, so 1 2 3. So next configuration it can be that is after xenon you can write like 5d 6s 5d 6s 5d 6s 5d 6s 5d 6s 5d 6s. Is that clear? So xenon, that is 54, and hafnium from lanthanum you can place like 1 2 3 4 5 6 7 also 5 6 7. Okay, 9 10 10 9 10 10. That clear? So just practice it, it's very important. So next you just add xenon having 54 plus 1 55, that will be 6s2. Again 54, and here you just see there is also filling of, since after lanthanoid these are known as 4f block elements and these are 5f block elements. So 4f14 must be added there. 4f14 including xenon, there must be 4f14. Okay, 4f14. So if you add this 4f14, then the configuration you can now mention xenon 54 plus 14, that will be 68, and this one will be 70. So 6s2 is there. Next 54 plus 17, 54 plus 17, that will be 71, 71, then this is 73, so that will be 2. Again here 14, 4, 18, okay, 54 plus 18, that will be 72. Then you just add 72, that is 74, that is 2. Is that clear? So 14, 20, 14 plus 5, that will be 19, 19 plus 54, 54 plus 19, 73. So 73 means that will be 2. Likewise here 14 and 6, that will be 20, 20 plus 54, 70, 20, here 5d 6, 14, 20, 54, 74, 74 means 2, okay. And here 14 plus 17, 21, 54 plus 21, 75, so 2. And here 14 plus 9, 23, 54, 54 plus 14 plus 9, 14, 9, so that will be 23, 23, 7, 7, 77, okay, 77, so that will be 1. And here 24, 54 plus 24, 54, 24, 8, 78, 78 means that will be 1. And here 24, 54, 24, 78, and this is 4f 14, 5d 10, 6 yes. So 24, 54, that will be 78. 78 means this will be 2. Okay, so these are the techniques I have told you how to mention their electronic configuration. Is that clear? So this is your long form periodic table, and depending upon the nature of the element, properties of the element, similar elements are placed in a particular group, and elements are arranged with increasing order of their atomic numbers. And at the initial these are alkali metals, at the middle these are transitional elements, and at the end these are your p block elements or non-metals, and this diagonal relationship represents your metalloids. That clear? So for today's class I have told you about long form periodic table, modern periodic law, and how the elements are arranged. Okay, so in next class we will discuss about their properties, periodic properties. Is that clear? Thank you.